Picture a force so subtle it hid from scientists for decades, yet so vital, it's why Earth is a lush living world, while Venus is a scorched wasteland. Welcome to Cosmic Chronicles. This is the story of the Ambipolar field, an invisible shield that's been saving our planet from Venus's fate for billions of years. This discovery isn't just a scientific breakthrough, it's why you're here breathing, living, and watching this video. Stick around because this cosmic journey will spark your curiosity and reveal why a tiny electric field is a game changer for life in the universe. Let's dive in. Earth's atmosphere is like a delicate bubble holding the air we depend on. At the poles, something peculiar happens. Particles blast into space at supersonic speeds, cold without any heat. Dubbed the polar wind, this phenomenon hinted at a hidden force baffling scientists for decades and challenging our understanding of the planet. The atmosphere resembles a leaky balloon shedding bits of hydrogen, helium, and oxygen daily. This loss connects to Venus, a planet that once had water but lost it all. To unravel this, consider plasma, the fourth state of matter, not solid liquid or gas, but a charged soup of particles, like lightning or the aurora borealis. In the ionosphere, 80 kilometers up, plasma dominates. In the 1960s, scientists thought Earth's magnetic field trapped in plasma in closed loops like a cosmic cage. Spacecraft over the poles proved otherwise. Plasma was escaping. This was like discovering a secret exit in a familiar house, revealing the atmosphere as a dynamic living system, not a static bubble. The polar wind isn't random leakage. It's driven by a planet-wide electric field, the ambipolar field. This invisible hand nudges particles into space, balancing the atmosphere to prevent excessive loss. Without it, Earth might mirror Venus, dry and lifeless. The field resides in the ionosphere, spanning 80 to 10,000 kilometers up. Sunlight strikes atoms like oxygen and hydrogen, knocking off electrons to create ions. These ions and electrons, like cosmic dance partners, are tethered by an electric spark locked in a tug-of-war with gravity. Electrons, feather light, crave to zoom into space. Ions, heavier, sink toward Earth. The ambipolar field maintains their balance, inflating the ionosphere like a cosmic balloon. This keeps the atmosphere denser at higher altitudes, acting as a natural shield against solar radiation, a cosmic sunscreen powered by electricity. This delicate balance ensures Earth remains a haven, safeguarding life from the harsh cosmos. In 2022, NASA's Endurance mission, named after Shackleton's legendary ship, tackled this 60-year-old mystery. Launched from Svalbard, Norway, the northernmost rocket range, a suborbital rocket soared 768 kilometers through Earth's magnetic North Pole. Equipped with a photoelectron spectrometer, it aimed to measure the ambipolar field's electric potential. The challenge was immense. The field's strength, a mere 0.55 volts weaker than a watch battery, demanded a device sensitive enough to detect the slightest electron slowdown. This was like hearing a whisper in a storm, a testament to human ingenuity. On May 11, 2022, Endurance succeeded, measuring a 0.55 volt change that confirmed the ambipolar field's existence and explained the polar wind's cold plasma escape. This tiny number was a cosmic key, proving the field drives plasma into space without heating it, a breakthrough akin to discovering a new fundamental force. The implications extend beyond Earth, offering clues to atmospheres on other planets. The mission's success owed much to Dr. Glenn Collinson, Endurance's lead scientist. Growing up in a small town, he stargazed with a cheap telescope, dreaming of solving cosmic puzzles. At a conference in Oslo, he recalled the moment Endurance's data arrived, tears in his eyes as decades of mystery unraveled. His story underscores that science thrives on passion, not just machines. The 0.55 volts powers the polar wind, carrying 3 kilograms of hydrogen and 50 grams of helium out of the atmosphere every second, 95,000 tons of hydrogen annually. Earth's vast atmosphere won't deplete oxygen for a billion years, but this loss shapes its structure. The field lifts heavier ions like oxygen, reducing their weight in the ionosphere, boosting the ionosphere's scale height by 271%. This keeps the atmosphere robust at higher altitudes, an extra layer of cosmic armor. Now consider Venus, Earth's twin turned rogue. Billions of years ago, it likely had oceans, perhaps life. Today, it's a 450 degrees C hellscape with no water and a crushing atmosphere. The Venus Express mission in 2016 uncovered why detecting a 10-volt electric potential 18 times stronger than Earth's. This supercharged field acted like a cosmic vacuum, stripping away particles, including water's building blocks like oxygen. Over eons, Venus dried up. Earth's weaker 0.55-volt field, by contrast, is a gentle breeze preserving our water. This difference is a cosmic stroke of luck, a lottery win for life on Earth. The ambipolar field's strength may be a universal factor in planetary habitability. Planets with weak fields like Earth could retain water longer, while those with strong fields like Venus lose it. This insight could guide the search for habitable exoplanets. Imagine discovering a distant world with a weak field, a potential Earth 2.0. Maria, a Venezuelan astronomer met while studying in Chile, brings this to life. Growing up near Mount Roraima, she dreamed of Venus named for the goddess of love. Working on Venus Express data, she was heartbroken to learn Venus lost its water. "It's a warning," she said. Earth isn't invincible. Her passion fuels advocacy for climate action, reminding us that cosmic forces alone can't protect our planet. Venus teaches that planets can change dramatically. Earth's weak field is a gift, but stewardship, reducing emissions, preserving water is crucial. The ambipolar field's bidirectional nature, with electrons pulling up and ions sinking, creates a dynamic equilibrium. On Venus, a stronger field tipped the balance, accelerating loss. On Earth, it's a gentle nudge, sustaining life from coral reefs to polar bears. The story continues with plans for a new mission, Resolute, named after a 19th century Arctic explorer. It will take further measurements of the ambipolar field, probing its role in atmospheric dynamics and planetary evolution. These findings could reveal how the field interacts with solar storms or climate change, perhaps predicting Earth's atmospheric future as the sun ages. What if we could engineer ambipolar fields on other planets? Terraforming Mars by tweaking its electric field to hold an atmosphere sounds like science fiction, but endurance shows what's possible when boundaries are pushed. This discovery is a window into the physics of planets, from Mars to distant exoplanets. The ambipolar field teaches a profound lesson. Earth's habitability is a delicate dance of cosmic forces. A weak electric field, a stroke of luck, saved us from Venus' fate. But luck isn't enough. Protecting our planet, cutting emissions, preserving water, respecting the atmosphere is our responsibility. Every choice shapes whether Earth remains a haven for life. That's it for this Cosmic Chronicles. If this journey ignited your curiosity, hit like, subscribe, and share with a fellow science lover. Let's keep exploring the universe together. Until next time, keep looking up.